Catus Maximus here. This time this is a full down to every last little piece tear down this Bosch PS10 iDriver. Actually, this is a repost of this video because I'd done the teardown, and then during that teardown I actually found and ordered this little Bosch battery set with a nice new 2020 2 amp hour battery. I was testing it, driving in this deck screw and this birch, just testing out the electronic clutch. It worked fine with its old battery. This is an ancient battery that barely works at all, but it seemed to be fine. But as soon as I put in this new battery, which I think is newer, pushes more amps, and on this old tool, and maybe, you know, when I bought this tool, it was sold, I didn't pay much for it. It was like $5 or something. Just because the guy thought that, you know, it had some problem and he didn't have the charger anymore. I think he already threw it away. Anyway, the first time I used it, it worked with that battery, worked on some of the clutch settings, so I put in the more powerful battery and it immediately burned up. Doesn't even work anymore in forward. It works in reverse, but the electronic brake doesn't work anymore, and in forward it just completely failed. So super disappointing. I paid 27 bucks for the charger and battery, so I think that's not too bad. I'm going to end up selling those on Craigslist. And buy a new battery for this Makita little impact screwdriver, which is really cool. Also a 15-year-old tool, but I think its electronics will be a little bit more reliable. Anyway, super disappointing to have this thing basically not be able to take the power of a more modern battery and literally let smoke out. Smelled terrible. I had to ventilate the house. Super annoying. Super frustrating about that, and makes me seriously question a lot of Bosch's tools if they're going to literally just burn up when you replace the battery. I mean, that's the only way to say it. It burned up immediately. The first time I put it on clutch 7 with a brand new modern 2 amp hour battery, just trying to drive a deck screw, which you would think this thing's pretty big, 600 RPM, it would do. It just fried itself. I mean, it was, not a lot else to say. In my opinion, the thing's kind of a piece of junk if it just burns itself up like that. I don't think I'll ever get any Bosch cordless tools if that's my experience. I mean, that's the only way to put it. How do I know others aren't going to do the same thing? So we're just going to shred this thing. Actually, I'm going to take apart the quick release chuck. People always kind of want to know how to take those apart. They're not easy. Let's zoom in a little bit here and try to take apart this chuck here. There's going to be a little snap ring, and it can be just an absolute bear trying to get that snap ring out of there. That's the real issue. And the trick is to try to use some O-ring picks and just get in between the two ends of the little snap ring. I'll zoom in even some more here. And just try to get under it somehow. That's what makes these so difficult. So I kind of like using the hook on one side because it just rotates around if you try to, or maybe like this. If you try to just push the pick under one end of it, it just spins around. So you have to have two picks, and you have to try to just pull it apart until one of the tips gets under it. And sometimes it is not easy, and sometimes they pop right out. There, well, it just fell off or flew apart. Somehow I magically found it. So you have that little snap ring. That's the deal with getting those out. We have like a little steel washer here. Guess I can't focus quite that close. Let's back out a little bit. We have the spring that retains the collar. Then we have the collar itself. And then in this case, well, I don't know where that other ball bearing went, but it looked like it had two ball bearings. It did have two ball bearings. The other one just rolled off. Let's zoom out a little bit here. Anyway, that's how you deal with the little collar. We'll get the rest of this apart. A couple of these screws are a bit too deep for my little driver to get out, or with the short bit. Kind of a shame because this seems like a nicely built tool. and the electronics just completely just failed me immediately. Nothing more disappointing than that, although I didn't buy it new or anything. It was used, and I'm out, you know, I'm only out like 35 bucks, the battery and charger, and this, so I shouldn't feel so bad, and I'll be able to at least sell the battery and charger, or hopefully get a replacement battery for this little Makita, which is the same thing. It's an ancient tool with an ancient battery, but this thing is like a little impact driver. It's pretty cool. It is a little impact driver, only 15 foot-pounds of torque, so it didn't sell real well for Makita, mainly because of that. It was just really, it was a really strong electric screwdriver, but the darn thing was super expensive. This Bosch iDriver is super expensive, and it shouldn't have burned up. Simply, you know, giving it a more modern and newer battery, to tell you the truth. Well, that screw doesn't want to come out. There was a little clip back here. I don't know if I showed that. Now we can get, and if people don't know, that's the idea of this. The big thing was that it had this articulating head, and it was supposed to be quite more than enough power to actually drive a deck screw. That isn't that big of a deal into a piece of lumber. And so anyway, I'm going to do this teardown much faster because this is indeed a re-upload. There's our case. I mean, everything about this physically, I mean, Bosch makes decent tools. It's just this thing completely failed. I'll mention some of the other things about it. It had, let's get the electronics out of here. There's our little spring mechanism. When you're pressing the button, whoop. There's our little switch. This is the little switch that goes for the clutch, and what it's doing is just activating this potentiometer. This control board just has a ton of circuitry in it, and I suspect part of what burned up is something dealing with the reverse switch, because obviously it didn't work in forwards, but still worked in reverse. But there's still something else that was failed because it didn't. The electronic clutch didn't work. The other big deal I thought was neat about this is it has this switch, but it is variable speed, and it had this odd boot. This is a dust boot, and there's a little magnet in the back of this, and so there's a little magnetic sensor. So as the switch gets closer and closer, it causes more current to flow, and so it's actually a magnetic variable speed. So anyway, when you adjust the when you press this button here, all it's doing is lifting up this little cog and allowing it to reseat in different positions there. There's the other half of the case. We'll get this apart. Continuing on here, just cut off the control board. Noticing this has a date of 2006, so that battery was 14 years after the tool. Even though it's a little disappointing, it just may not have been designed for the kind of current the new batteries can surge, because part of the deal with the old lithium-ion batteries is that they just couldn't push as many amps as more modern ones, and modern ones can push more amps, and it probably just surged more power than the little reverse switch could take. I don't know if it's a reverse switch. There's all sorts of surface mount components on it. I mean, it uses these power transistors to drive the motor, and they have a little heat sink on there. You know, they even have a capacitor right there, right at the motor. So I suspect it's more than just a switch that has failed on this. So anyway, what are you gonna do? Knock this the rest of the way apart. And hopefully I can recover a little bit of money to, even though this battery may be really old on this Makita, this thing is at least a little more satisfying and is direct drive. No variable speed or anything on it, so nothing to quite go wrong in the same way. So we can get a closer look. 4 screws. So disappointing. Once again, I'm going to say that a lot in this video because everything else is great. It just sucks when it burns up. We have this really nice aluminum casting here. How it works is you have the motor. Since this is a lower speed one, 600 RPM, this is going to be a triple reduction gearbox that we see. We have a cast aluminum front ends so it can have a lot of support. The final drive, since there's a lot of torque, those are big bevel gears. It uses one bevel gear, hooks to a second gear, which is right in the center line. That's what allows this thing to pivot around, because it pivots around that transfer gear. The thrust loads are taken by a bronze, it's not sleeve bearing, it's a thrust washer. Not a thrust, I mean, I guess it's a bronze bearing, but it's not a rolling bearing. But then they do include a ball bearing here, I suppose, because when you're in situations like this, there's going to be some lateral load, and so that helps make it more efficient energy transfer or force transfer. Obviously, if you're like this, then the forces are, I guess it kind of wants to twist out, but it's a little more balanced. But then it just has a really thin little axle that goes through it to kind of hold it in place. This is what really impressed me, is that this is actually held in by 3 bearings. We have this little integrated bracket, and if we pull out the whole spindle assembly, it does have a one-way clutch in there. But I thought this was interesting because it actually has a little thrust, I guess, thrust and support bearing on the back there. We have a sprag clutch. Where are our little sprag? There we go. These are the little sprag pegs. What ends up happening is this interacts with the pegs and causes them to push out on this collar. And so the tighter you try to turn the spindle, the harder it presses these little guys out. But when it's the other way around, when this is turning, this is pressing against the side of the rollers and prevents them from locking up. So that's how it can be a one-way clutch. It prevents power from going this way, but does allow it to go this way. It also explains why there was 3 elements, because the sprag clutch was there. This part of the spindle is not one piece with this. So this gear, to keep it from wobbling, they had to have a little sleeve bearing on one side, and then here this is a ball bearing. That's what keeps this going straight. And then they used a larger size ball bearing on this side for the actual spindle, and I needed snap ring pliers. Okay, I got my snap ring pliers, and then of course the other end of the sprag clutch, this is actually just a 1/4 inch hex. This is just broached all the way through, and then that's how it actually drives the spindle. And we'll pop this snap ring off of here and see if this bearing just wants to pop off. Be careful with working with snap rings. They are very stiff. And this one doesn't want to cooperate quite as much. Sometimes they want to get jammed in the groove, which is what this one seems to want to do. And pause the video again if I can't get this. Ow! That snap ring was an absolute bear to get off. For some reason it was just really stuck in the groove. This bearing is actually still press fit, or this shaft is still press fit in the bearing. Fortunately, I will keep this bearing for something because I can get a socket around it, and you can see there's just a little shelf here, but I still have access to be able to support it by the inner race, so I'll be able to hammer that out without damaging the bearing. Now, hopefully, this snap ring is, and I pinched the crud out of myself. Just not been a good day. Spent a bunch of money on a charger for a battery for a tool that immediately failed. And then I get hammered trying to take it apart. How nice is that? So I wonder if this is gonna just push out, if I'm gonna have to, yeah, I'm gonna have to tap that out too. Well, I tried tapping that out because I assumed it would be in there, but not super tight because, you know, the ball bearing is retained by a snap ring. No, this thing is like pressed all the way through like this centered kind of spacer center section. And now that I've damaged it, I don't want to try to use the press because I've already bunged up that surface and I have to use a real thin punch. It's going to be a little bit dangerous, so I'm not going to be able to pop that gear off. Surprising how robustly they put it in there. These were also kind of pressed fit in there, but once I got them moving, I was able to get these retention pins out of the gearbox. So we can take a look at the gearbox. This is super tight on there. This got really tight. Such a shame. It seemed that Bosch really tried. It just, I guess they just didn't really think that their own batteries and this tool would be used so much further in the future. So anyway, this is this entire housing. It is keyed, so it goes on a specific direction. Here's our gear. There's another ball bearing. I mean, so far 1, 2, 3 ball bearings. Quite a few. I don't know what's really holding this together still. That's a little bit interesting. Just kind of moves back and forth a little bit and then just stops. There we go. We can twist this gearbox. If you most of these gearboxes, and I thought this one was stuck, but now that I'm kind of upset, almost all cordless tools and that type of stuff, these gearboxes are keyed where you have to twist them and then they'll come apart. And I thought it was all metal, but that's actually obviously plastic gears on the first stage. This is greasy. I need to get a rag here. Alright, finally finishing with this teardown. Let's. Second stage gears are indeed metal, so only the first stage gears. And I don't know what's holding all this. This is kind of just, that must be, this must be a pressed together assembly where they pressed all this together with the bearing already in this plastic housing into that carriage, and that's what's holding it all together. And it is indeed only 2 stages. I thought it was a 3-stage, but I guess I was kind of thrown off by that collar. I assumed there's another stage in there. Instead, it was just this big output bearing. And apparently it is captured in here. Well, we'll go and finish the teardown there. After fidgeting around, that's indeed the case. This bearing and everything is all sandwiched, and this was all kind of pressed together as an assembly. And you're not taking this apart without, you know, a gear puller. This is going to be pressed on pretty tight. I mean, you can't buy any of these individual parts, so that I see why they use press fits, because you don't have to cut any threads or anything, and all you have to do is make sure that the friction of the press fit, which can be, you know, super high, you don't need much diameter to have just be able to take a whole lot of torque, so it makes sense that they just decide to press fit it all together. Motor is a decent motor, fan cooled. It has, it's kind of hard to see in there, but it does have copper plated or copper composite brushes. The motor only has sleeve bearings. Anyway, sorry for the re-upload of this video, but anyway, that was my disappointment. Bought the tool, bought a battery and charger for it, and had the tool fry itself. The first use, I mean, come on, Bosch. Anyway, I really appreciate everybody who's been watching and subscribing. If you haven't subscribed, please do. Till next time, Catus Maximus out.